My name's Michael. I work for App IT, the Gentix department, and we deal with content management systems. As I mentioned before, I'm leading the UI team, where we're using Angular to build user interfaces for these content management systems. So we built our own UI component library, which is called the GentleI Core. And we use that in our own products, and it's now used in, I think, 4 or 5 of our products. It's also open source. It's available on GitHub. And in this talk, I just want to share a few lessons and hopefully some insights from what we've learned over the 2 years we've been building this. So, well, let's start with the basics. So what is a UI component library? You probably all know this, but I'll go over it quickly. It's just a set of ready-made UI components which allow you to more easily, more quickly build a website or an application. So they look something like this. So it's a set of the most commonly used things: form controls, navigation, buttons, alerts, and so on. So you've probably heard of one of these type of frameworks. Has anyone used one of these before? Yeah, exactly. Everyone's used something like this before. So, yeah, so we know the concept of a component framework, or component library. So why are these important, or why are they useful? Why are there so many of them? Why have they been around so long? Why does everyone know Bootstrap? So the main thing you'll be aware of when you've used it is it speeds up development. So not only do you not have to actually implement all these different components yourself, like lots of them are simple, like inputs and buttons are not too difficult. Some are more complex, date pickers and so on. So it saves you having the time. It saves you the time of having to implement stuff like that. Also, and maybe even more importantly, it saves you the time having to think about how you're going to implement it. Like, what's the best way to implement a date picker? You don't want to have to think about that every time you start an app. So these kind of frameworks or libraries solve that problem. You don't have to think about this stuff. You can just start dealing with the important logic that's really part of your app. And they solve problems once. So, you don't have, if you have a shared library amongst all your applications, you don't have to then deal with the same problems every time. It becomes tedious. It's just a waste of time. If you've solved it well once, you should then be able to share that, and no one has to solve that problem ever again, ideally. And part of that is that they offer tried and tested solutions. This is really important because it's pretty easy to write components, but it's hard to write robust, well-tested components that cover all the different edge cases that come up in real use. So a library that's used by a lot of apps comes some way towards reaching that goal of being actually reliable. So it takes some use to get to that stage. And lastly, they enforce a consistent style, a consistent look, a consistent user experience across all the applications in which you use it. So this is often a problem, especially in larger companies, where you have lots of different teams working on their own applications. And what can happen is that they can work in kind of their own little bubble or their own little silo, and they build their apps and they have a certain look and feel. And each individual app might be great and it might look okay, but taken as a whole, it can be very inconsistent because they're not sharing common patterns and common solutions amongst themselves. So for the end user, if it's, for example, a suite of applications, it can be very confusing for an end user if one application handles notifications in this way, and another application in the suite handles them in a totally different way. The user will be lost, and the user, as far as the user is concerned, this is one company. Why do the user interfaces work differently? It doesn't make sense. So this solves that problem, and this is, it kind of gets into the area of user experience design and style guides and this kind of thing. So it serves a kind of a dual purpose there as well. So a bit of background. Some of you might be wondering why any sane person would go to the trouble of building their own component library when there's already stuff out there. Bootstrap's already there. Why do you need to reinvent Bootstrap? So I'm going to explain using a timeline. This is the past. Oh, laser. This is the past, and this is the present, okay? So we'll start off at the beginning. So according to many theories, it started with a very large explosion, and then there was these guys. We're going to fast forward a little bit now. February 2016. In February 2016, we started working on these UI apps. I don't know if it's easy to see there on the screen, but we have here, what's that?
First commit.
First commit, yeah, that's right. Angular 2. It's called Angular 2 back then, remember? It wasn't just Angular, it was Angular 2. Angular 2 Beta 2. So, yeah, it was in beta, it was very early, but we'd made the decision to use Angular for our UI apps. And we actually started a ground-up rewrite of the whole user interface of our main CMS. So Angular, anyway, continued to evolve. You know, there was a new router at some point. Remember that time when you had to refactor for ng modules? Another router. So I know, you all feel the pain. About 2 years went by, and then actually in the last few months, maybe 2 or 3 months, we've seen major stable releases of things like Bootstrap for Angular and Angular Material. So as you can see, way back then, near the Jurassic times, there was nothing out there. So this is why we decided to build our own. So the first thing we realized was that it's pretty hard to build UI components. It's harder than you think. Let's take, for example, a select form control. So what do you need to think about to build one of these? Well, of course, you've got the basic functionality. It's a list of items. You can select one, it'll change the value. So this is what you would initially think about. Oh, I need to build a select. Well, I need a list of items, select it, change the value. How hard can it be? When you actually get into it, you realize there's a bit more to it. You got to think about things like, you know, this drop-down might not always be visible. Maybe it's too close to the bottom of the screen. What do we do with it? Do we make it go up? Or maybe it's inside a div with overflow set to hidden. Then what do you do with it? It's going to get cut off. So you need to deal with stuff like that. Maybe it needs to be scrollable if there's lots of options. You need to have scroll support. It's got to handle focus. It's got to be accessible. It's got to emit the right events. It needs to implement its disabled state. It needs to be able to have the required support. It needs to support multi-select. It needs to support option groups, if you've ever heard of those. Needs to have keyboard control. And that doesn't mean just that the up and down keys work. The space key, the home end keys, escape key. When you press a letter, it's going to jump to you know, that option that begins with that letter and so on, and scroll through them. And it's also got to look okay. So you can kind of get a flavor that there's quite a lot to it. That's just one component. So we needed at the time to start shipping pretty quickly. We actually made our first commit to the CMS UI about 1 month after we started this library. And so we needed some way. We couldn't build everything from scratch, so we cheated a bit. And we took an existing framework with all the styles and the JavaScript and just wrapped it. The one we chose was Materialize. It's an implementation of material design. And it's like Sass, CSS, and jQuery. So the way that we started off was like this. We would just take the Materialize component and we would just wrap it in an Angular component like this, and like hide all the jQuery stuff inside there. And it normally looks something like this. In the ng on init, we would just use jQuery and just, you know, initialize the plugin like you normally do with jQuery and kind of hide it away. I tried to hide it away like that. And this worked, kind of worked, but it involved lots of hacks and it was pretty buggy as well. So once we had a little bit of time, we were able to return to these components one by one and rewrite them just using the native Angular APIs. Like this. I wish it was so easy. And eventually, we were able to drop the materialized JavaScripts and the jQuery dependency altogether. So here's the real commit. So for the most complex components like select, for example, it was about 9 months before we actually reached that stage of getting rid of all the old cruft and doing it the proper way. But at last, we were able to break free of jQuery. So a few notes on that whole process. It's a pragmatic way to start. It worked, it got the job done. So there is value in this. You know, in real life software development, you cannot always do the right way, you know, all the time. You have to take into consideration deadlines and so on. So in this case, it worked out quite well. However, it did make everything less testable and more error prone. And the basic problem we ran into was this, that these like older or jQuery based frameworks are not designed with the single page application use case in mind. So for example, with one of our apps, one of our customers would have, they will have the UI open all day and the page never refreshes all day. So plugins that we were using with Materialize would register event handlers, and maybe they wouldn't clean them up, and they would be taking control of the DOM and moving things around, and Angular wouldn't know about it, and then there'd be change detection errors because it had changed some DOM without Angular knowing about it. So it led to all this series of hacks where we had to kind of go in, do some manual change detection triggers and so on like this. So it gets difficult, and my advice then is to pay your technical debt as early as you can, because it's worth it. It's worth just spending the time saying, right, that's it, we're going to clear all this stuff out, and it makes the rest of the development much easier. In fact, I would go as far as to say, just avoid jQuery altogether in an Angular app. Do I have agreement with that? I mean, I think maybe there is a use case where you really need it. And if you really do need it, I would say, don't do things like using remove and append to change the DOM around, because Angular will hate you if you do that. Angular has a bunch of APIs for doing stuff like that. It's view container ref, component factory resolver, and so on. So if you do have jQuery in there, just try and leave the DOM alone as much as you can and let Angular do its thing. Okay. Another early problem we had to solve was how to develop our components in isolation. And what I mean by that is that if you're developing a select component, you don't want to have to use the select in a real app and then import it and load the real app just to see what it looks like. You want to be able to just test it on its own. So, and this ties into the fact that, like, as developers, we benefit from having very tight feedback loops, being able to get feedback with as little overhead as possible. So the solution we came up with was we built a very simple demo app which had one page for each component, and we would just open up one page, and we would just be able to then develop that one thing, refresh that one page, and see the results. And it also serves as documentation, which I'll show a little bit later. So another option that's probably wasn't available at the time, but is now, is something like Storybook. Has anyone used that before? Or has anyone seen it before? It's really, yeah, some people. It's kind of bigger in the React world, but it's now, you can use it with Angular. And it's like it's an automatically generated living style guide, which allows you to just exercise one particular component in isolation and change the inputs and test the events and so on. So it saves you having to build a whole application to test it. So check it out if you ever need to build a library yourself. All right, documentation. Documentation is really, really important for a library when you have people who aren't you using it, especially. Now we have a couple of other teams within our company who use the GentleI Core, and they really need the documentation, and myself and Leon, who wrote the library, we also need it. I mean, I think I use the documentation every single time I have to do something with it. So it's really hard to keep docs up to date. That's always the problem with documentation. Every time you add a new input to a component or have a new event, you need to update the docs. Otherwise, they become useless. If the docs are unreliable, you'll never trust them, and they're as good as useless. So the good thing is with TypeScript, it actually provides a lot of the information that we need, the important information for documentation in the type annotations that we put into our code. So we decided to try and use that information in order to generate our documentation. And I'll show you a little bit what it looks like. This is absolutely useless. I should have used a light theme. Anyway, on here is the component code for the select. And it has a documentation block at the top with some, like an explanation and some code in a markdown code block. And that gets translated over here into the actual documentation. And this part you see here is pulled directly out of the source file. And likewise, another black square. another black square here. These are the inputs for the component. And again, we pull the information directly out of the source code and make a table like this, which shows the types, the default values, and the comments. So in this way, you don't have to think about the documentation so much. You just write comments as you would as a regular course of development, and the docs will be generated and they will be correct. How do you do this? Well, there's a number of different ways that I know of to generate documentation from the source. So for example, Angular.io, the documentation you see on there, is generated by a tool called Jenny, which members of the Angular team built. And this is a general purpose documentation tool. They use it for Angular 1 docs as well, and it's not just for TypeScript. I had a look through the repo that they use to generate, and it looks pretty complicated to set up, but it produces very good results. Another option is to use a tool like TypeDoc, which uses the TypeScript language service to parse all the code and pull out all the stuff and automatically generate these docs. This is a good way to do it because you can trust the TypeScript compiler essentially to give you the right information. The one criticism I have of that kind of approach, often with these, in general, auto-generated docs, is they can end up like really verbose, and sometimes you think I might as well just read the source. But anyway, it's a good option. Another option is to use regular expressions. So this is a great approach if you have the idea that the problem is much simpler than it actually is. This is the idea that I had when I was building these docs. So we currently use this method to extract all this metadata. And if you also feel like you would like to go down this path, I've saved you some trouble. And here is the regular expression we use to parse a component. So the slides will be available on the meetup site, so you can copy and paste that.
You have to make a t-shirt.
Yeah. Very long t-shirt. All right. So publishing. So when you've built your library, you got to think about publishing it so it can actually be used in a real application. So there's a few different aspects which are interesting to know about and to consider when you come to publish any library, really. So how are you going to handle the styles? You could transpile the, we use Sass to write our styles. You could convert it into CSS and just export the CSS, or you could leave it as Sass. We decided to leave it as Sass and just the consuming library just has to assume it's Sass. The advantage of that is it makes theming easier because for those who know Sass, they have the concept of default variables, and you can override them in your app, and it makes it quite nice to theme things and change kind of certain aspects. Another thing is, should you use global styles or encapsulated styles? We use global styles, so we use view encapsulation strategy none. And as far as I can tell, that's the only sane way to do it for a library like this. And I checked with the Angular material library and they do the same. So it must be right. The next consideration is, how do you export the JavaScript? You can export as common JS modules. Now it's more common to, or it's becoming more common to export as ES modules using the import-export syntax. The way that I know the Angular team recommend doing it is using this thing called flat ECMAScript modules, which is kind of using exporting everything as an ECMAScript module, but putting it all in one file. That has benefits for tree shaking. It means they can eliminate dead code more easily. I think at the moment we don't use that. We're using a less sophisticated method of exporting the JavaScript. Another thing you have to do if you're making a component library with Angular is you have to inline the templates. You can't use template URLs. When an app consumes that component, it won't be able to find a template referenced in a template URL, so you have to inline them all. There are tools to automatically do this. We're using a gulp-based build system, so we're using one called gulp inline ng2 template, catchy name. Angular material have a custom script which will just kind of replace the template URL with the actual text. And of course, if you want to support ahead of time compilation, things get a whole lot more complicated, and you do need to support this. Has anyone got experience building a library that supports ahead of time compilation? Yeah, it's difficult, isn't it? It's difficult. There's a couple of main things you need to think about. Your library needs to produce these metadata files, which are produced by the Angular compiler, NGC. If you don't have those, no application will be able to use your library in an AOT context, which is pretty much useless because every production app ships with AOT support now. Also, you've got to make sure you're not using things like private fields in the templates and all these little kind of gotchas that you have when you're trying to do AOT. Okay, so a few concluding thoughts. If you're going to start a project now, there are lots of solid choices for UI frameworks. You don't need to write your own. But maintaining your own UI lib does have benefits. For example, we might be working on one of our UI apps and we find a bug. Well, then we can just jump into the GentleI Core repo, fix the bug, publish a new version to NPM, and then carry on with our day. Now, if you were using, for example, Angular Material, I think it would be hard to get all that done in the same afternoon. So the other advantage is you have a very deep understanding of the component library. It's not like a black box as it can be when you're using someone else's code. If you do find that you need to write your own library, then there is such thing as the Angular Material Component Dev Kit. Has anyone heard of that? Okay, yeah, a few of you. So the basic idea is that the Angular Material team, they're producing a library which is extremely high quality. And what they did is they took some of the core parts and they extracted it out into a development kit which you can use to build any kind of UI library. So it handles things like making overlays, projecting content in the DOM, scrolling, accessibility. These kind of things that you don't initially think of as important, but actually become the most important thing and the most buggy parts if you try and do them yourself. So the component dev kit handles all those things for you. Apparently, I've never used it, but that's the idea. If we were to start again now and we had to write our own, I would probably seriously consider using that. And the last interesting development in this area is Angular Elements. Have you heard of that? Okay, it's a kind of experimental technology that they've got going at the moment. And the basic idea is it's a way to allow you to export an Angular component as a web component, a self-contained web component. So for example, you could build a select component, a fancy select component, and just export it as a web component, which can then be used in any website, in just a plain HTML website, in a React app, in a Vue app, or whatever. It's completely agnostic. So this is under development at the moment, but I've read some kind of hints from the Angular team recently that it will be something available, like prototyped or in experimental in version 6 and possibly released in version 7. So it's not too far off, maybe 6 months or so away. And this will be like a really huge thing if you have a component library like we do, because then it means that it becomes a completely universal front-end library. So if we have other teams in our company who are using just not Angular, using any kind of framework or no framework, they can use the same library. So you can build one UI library in Angular and the whole company can then use it in any context. So it's really exciting, and I think that could open up some like massive possibilities. Okay, so thank you. That's all I have for you. We're hiring. I got some Comic Sans in there. So yeah, that's it. If you got any questions, ask.